Hello, everyone, and welcome back to our discussion in trigonometry. So, here we're going to proceed to the next topic, and that is the unit circle. Here's the thing though, this question is just similar from the discussion we had about the length of the circular arc. What is the point of discussing the length of the circular arc if the trigonometry, the subject itself, is about triangles? Similarly, in this case, what does unit circle contribute in this subject? Because this is a circle and trigonometry is about triangles. There are two reasons. And what are those reasons? First reason is you will know the special angles. Okay? Special angles has something to do with the trigonometry. And speaking of trigonometry, that means it has something to do with the triangles as well. In this case, right triangles. I mean, special angles are also applicable to the other triangles, don't get me wrong. But here, in this case, it has something to do with right triangles, okay, to be particular. Again, special angles can be also applied in other types of triangles. But here, in this case, it's focused more on the right triangles. So these are the two reasons, okay, special angles and right triangles. And of course, the relationship between the two. Okay? So these are the two reasons why we need to study the unit circle. So, first and foremost, what is unit circle? So unit circle, this is actually the graph. I graphed this from the Desmos. Okay? So as you can see, yeah, it is a circle, of course. All right? And as you can see, if I'm going to draw a radius, like if you're going to notice, the center is here. Okay, the center of the circle is here. Then if I'm going to draw the radius, let's just say from here to there, the measurement is 1 unit long. From there, it's also 1 unit long. From there, it's also 1 unit long. So a unit circle is basically a circle, of course, that is centered at the origin, and its radius has a length of 1 unit. All right? Then there's another thing that I would like to add, and that is the formula of this unit circle. And what is the formula of the unit circle? This one. This is the standard equation. But if you want to know the general, what I mean by general equation is a type of equation where all terms are grouped in one side. Here is the formula, which is x squared plus y squared minus 1 is equal to 0. So this is the general equation. Again, general equation is about grouping all terms in one side. So all terms here, I transpose 1 to the left. So we have this one. So you see? Now here's the thing. Where does this equation come from? So if you recall the lessons you have in pre-calculus, I do believe, which is the conic sections, one of the conic sections discussed in that subject is circles. Each of the conic sections has their own general form and standard form. All right? The general form of a unit circle is this one. Okay, ax squared plus ay squared plus bx plus cy plus d. Although there are some, or not some, but in other textbooks, it has bxy, right? Bxy. Here, there's no xy here, right? So here, cx plus dy plus e. So what does that mean? It means that the terms of the coefficient of the x squared and y squared are the same. They are the same. So if they are the same, then you can call this as a circle. But you know, there are actually conditions for that. You will know that in your discussion, or maybe If you have discussion in this conic section, I think you know what I mean. Okay. Then we have the standard form of a circle. The standard form or equation rather of the circle is what? The square of x minus h plus the square of y minus k is equal to r squared, where the center of the circle has the coordinates of hk and r is your radius. Okay, r is your radius. Now, this equation is actually derived from this. Okay, it's derived from this. Now, I'll show you how. So first and foremost, the circle is centered at the origin. So what does that mean? It means that if the center of the circle is centered at here, that means the coordinates of the center is the coordinates of the origin. Or in other words, its coordinates are 0, 0. That means your center is h and k, right? So it is 0 and 0 respectively. So that means if we substitute 0 in here for your h and k, you will have x minus 0 squared plus y minus 0 squared. You will have that. Then your r, which is your radius, has a length of 1 unit. So that means your r is 1. Now let's simplify this one. X minus 0, x. Square it, x squared. Y minus 0, y. Square it, y squared. Then is equal to 1 squared, 1. See? That is the standard equation of unit circle. Why do you need to know this, by the way? So that if you want to know the graph of it, just type this one in your graphing calculator. And this is the result. Okay? And we will be using this circle for us to find the special angles and its relationship to the triangle. So with that, we will discuss it into 3 parts. First part, actually I already told you why study or learn because of the special angles, right? And the right triangles. Although it could be applied in other triangles as long as they have special angles. Okay? But in this case, it's special angles and right triangle because these two have something to do on these two are actually related to each other. Okay? You will know that later. So here, there are 3 things that we will discuss. First, what if we divide the unit circle by axis? Second, what if we have a inscribed square, or meaning square inside the unit circle? And last but not the least, what if we have an inscribed hexagon, or in other words, having an hexagon inside of this circle? All right? So with that in mind, let's now begin at this first part. Let's start with this one. What if we divide the unit circle by axis? So listen carefully because what I'm going to do here is more on a discussion or lecture. So not more on what I call this one, not more on giving you exercises. All right. So what do I mean by dividing the circle by axis? What I mean here is that this circle will be divided by what? By 4. Because you see, we have the axis here. And if you divide it by 4, what will happen? What happens is that you have 4 arcs. Okay? 4 arcs. Okay? It's being cut off into 4 by the axis. Okay? So yeah, it's been divided by 4. So you have we have 1, 2, 3, and 4 arcs. Okay? So once again, we divide the circle by the axis. So what happens? Because of the intersection between the y-axis and x-axis, you have 1, 2, 3, and 4 arcs. So now, let's try this one. imagine that you're rotating. Okay, you're rotating from here, which is your initial side, by the way, up to here, forming a quadrantal angle. Okay? Remember that in here, we will have uh, angles of 0 degrees, 90 degrees, 180 degrees. This is 270 degrees. Wait. Uh, I'm just going to draw an arrow here. Okay? This is 270 degrees. And here, 100 revolution will give you 360 degrees. So, what if you start rotating at this point, going this point? Okay, so this is your terminal side. Okay? Now, I want you to find the arc length. Okay? From this up to this. Here, it shows that you form a quadrantal angle of 90 degrees. So, what are we going to do? So yeah, it's easy. Get the arc length, okay? R times theta. Your R is your radius. And remember, the radius of the unit circle is 1, right? Times theta. Your theta here should be in radians. So here, I'm just going to go straight forward, okay? Because I already discussed to you, how would you convert an angle that is in degrees into radians? So this one is just the same as pi all over 2 radians. So multiply them together, you will have pi all over 2 units. That means that at this point, from here to there, forming a 90-degree angle, the measurement of this arc is pi all over 2 units. Okay? Okay, so that's good. Now, what if we exit further until we reach 180 degrees? Okay? Like for this case, from here up to there. Okay? So you form exactly 180 degrees. And also, you will form an arc length. Okay? From start to finish, you will form an arc length of this one. Okay? So as you can see, it's a semicircle. So again, the angle formed here is 180 degrees. So let's find the arc length here. Okay, similarly, just, yeah, it's the same thing. The difference is the angle. So, okay, find the arc length of this one. So radius times theta, 1 times the angle here. So this is pi radians, sorry. So multiply them, you will have pi units. Okay, so that means from here going there, you will form what? Pi units. That's basically the length of the semicircle. Okay, or in other words, length of the arc length. Oh wait, length of the arc. Or in other words, the arc length of the circle when you form 180 degrees. Now let's exceed even further. Okay, until we reach 270 degrees. So from here, going there. Okay, from here, going there. So when you go here, you will have a terminal side here. And with that, from start up to the end, you are going to have this arc length. Okay, so it seems like this is the third fourth of the, or sorry, three-fourths of the circle. You get me? Because we got 1, 2, and 3 parts of the circle, and this one is not included. So this is three-fourths of a circle. You get me? So here, let's find the arc length. So this one, okay, we can do it the same way. 1 times the angle here, this is 270 degrees. So 270 degrees, this is just the same as, wait, I'm just making sure. Pi plus pi all over 2. Okay, I'm just making sure, guys. So this is 2 pi, yeah, it's 3 pi. Wait, let me erase this one. This is 3 pi all over 2 radians. Okay, 3 pi all over 2 radians. So if you're going to multiply them, you will have 3 pi all over 2 units. So that's how long is your arc length if you rotate up to 270 degrees units. Okay, so you will form 3 pi all over 2 units. Now, lastly, what if you rotated in one whole rotation? Okay, one whole rotation. So that means you covered the entire circle. So from start up to here, okay, the same place where your initial side is. So you what? Covered the entire circle. So what would be the arc length? So the arc length here would be 1 times 2 pi radians because you've covered 360 degrees in total. Because one whole rotation or one whole revolution is what? It's 360 degrees or 2 pi radians. So this is 2 pi units. So that means one whole circle, one whole arc length of a unit circle is 2 pi units. Okay? So what can we observe here? Well, first thing is that when we get actually the arc length, what happens? Like, let's just say we start from here. From this side only, like 90-degree angle, you will form a length of pi all over 2 units as your arc length. All right? So from here to there, it's pi all over 2. But you see, the angle there is just the same as pi all over 2 radians. You know, the angle here in radians from 90 degrees, it's pi all over 2 radians. And the arc length here is pi all over 2 units. So what can we say? We can say here is that the angle form is just the same as the what? The length of the arc length. The length of the arc or circular arc rather. Because you see, pi all over 2 radians, right? Then here the arc length, it's also pi all over 2, but different units. So here there's no centimeters, meters, so we represent it as units. So therefore, the magnitudes, or rather the value, they are the same. Get me? Just like here also, when you reach an angle of 180 degrees, the radians you will have is pi radians. But when you get the arc length from there up to here, like midway, you will also have pi units. So that means, numerically speaking, they are the same. You know, numerically. It doesn't matter if it's positive or negative sign of this angle, but in terms of value, they are the same. You get me? They are the same. Okay? Despite their signs and their units. Okay? So we can say that the magnitude of the given angle, okay, if that is intercepted by the arc length in a unit circle, is just the same as the magnitude of the arc length itself. Okay? So that's good. All right? That's the first thing that you observe. And what's that again? The value, the magnitude rather of the the magnitude of the angle is the same as the magnitude of the arc length. So we have pi radians is the same as pi units. Even if this is negative, like negative pi, for example, it still be pi. You get me? So they are just what? The same. All right. So what's next? Okay. So here, I'm just gonna erase this one. So pass forward. All right. Pass backward if you want to copy or something. Okay. So here, let me write again the quadrantal angles. Okay. This is 270 degrees, and one rotation is 360 degrees. Okay. So now, what are we going to do? Let's find the coordinates. Coordinates where the terminal initial side. Okay. So you stop here when you form 90 degrees. Okay. So you stop here when you form a 90-degree angle. So at this point, wait, let me erase this one. It's thick, if you know what I mean. Okay. So from here to there, you form a terminal side of this, right? Now, at this point, exactly at this point, what will be the coordinates? At this point, what will be the coordinates? So the coordinates of this one is what? 1, no, wait, that's wrong. Not 1, 0. It's actually 0, 1, 0, 1. Why is it 0, 1? Okay. Well, horizontally speaking, you can't find, wait, how should I say this? Horizontally speaking, it's not moving from left to right. It's not moving from left to right. Okay. Away from the origin. Okay? Rather, it's only the vertical side that is moving. So it moves 1 unit upward from the origin. Remember, guys, if you're going to plot a point, because this one, what we're going to do is plotting points. And in plotting points, you have x, y. Your x, these are basically, yes, your x value. But in other words, this is basically the distance you traveled or the distance that the point travels in what? In horizontal way. That is away from the away from the center. While your y value, on the other hand, this one tells you, okay, same thing, y value and the distance you've traveled away from the center, vertically speaking. Like for example, let's just say 2, 1. For example, okay? For example, let me use a different color, maybe red. Okay, 2, 1. So that means you travel 2 units away from the center. And since it's positive, so you will go to the right. So that means 0, 1, 2. Okay, 1, 2. Now you have 1 unit. So here it's positive. So that means you're moving 1 unit upward to the what? Upward from the what? From the center. So that means 0, 1. Okay? Then you plot the points, like connect them. So from here, since this is your 2, so we connect them. Then here, we connect here the y value of 1 horizontally. There we go. So this is the location of 2, 1. Okay? So I'm just giving you a recalling concept because that's what we're going to do here. All right? So I hope you get what I mean. If not, I suggest you should review your basics in algebra because this is one of the basics that you need to learn. Anyways, okay. Okay. So yeah, once you reach 90-degree angle, wait, let me just change my pen color. Once you reach the 90-degree angle, you will have the coordinates of 0, 1. Okay? By the way, we're not only including 90-degree angle, we're also including its coterminal angles. Okay? We're also including its coterminal angles. What are the coterminal angles of 90 degrees? So we can have negative 270 degrees, right? Or 450 degrees. They're the same. So that means if, let me erase this one. So that means if you have if you have achieved an angle that is having an initial side here and a terminal side here, okay, you will have the coordinates of 0, 1. Okay? All right, you get me? So we're not only including 90 degrees here, but we're also including its coterminal angles. All right? Now, how about if we exceed further? Like, what if we reach like until 180 degrees from here to there? So here, what will be the coordinates of this point? Okay, this point. Here, you will have -1 and 0. Okay, why is it -1? Because you see, horizontally speaking, the point is 1 unit away from the origin, but since it goes to the left, so it's -1. Plus, it's on the axis, so that means it's not moving up or down, so it's 0. Okay? So that's it. Okay? Now, what if we go further until we reach 270 degrees angle. Let me erase this one. Okay. Let's start from here going there. 270-degree angle. So what would be the coordinates here? So the coordinates here, what do you think? What do you think, guys? It is 0 and -1. Okay, 0 because it has no horizontal direction because it doesn't move from left to right away from the origin. -1, yes, because it moves away from the origin, but what do you call this one? But it's going downward, so it's negative. And now, last but not the least, what if you go further? Okay, like what will be the coordinates here? So we have 0 degrees and 360 degrees. Okay. So here you will have, what do you think will be the coordinates? So you will have 1 and 0. Okay. 1 and 0. So here are the coordinates given based from the angles form. Okay. So if you reach an angle that is in 90 degrees, expect that you will have 0, 1. If you reach 180, you will have -1 and 0. If you reach 270, 0, -1. And if you reach 0 degree or 360 degree, you will have 1 and 0. Okay? Let me erase it. By the way, again, we're not only including the angles here given, but also its coterminal angles. So in summary, 90 degrees, -270 degrees, and other coterminal angles of 90 degrees will end up having the coordinates of 0, 1. Okay? 90 degrees and other coterminal angles of 90 degrees, they will end up having the coordinates of 0, 1. Next, 180 degrees, -180 degrees, and other coterminal angles of 180 degrees will, wait, let me just erase this one, will end up having the coordinates of -1 and 0. Next, 270 degrees, -90 degrees, and other coterminal angles of 270 degrees will end up having the coordinates of 0 and -1. Okay, because when you go from here, going there, you'll form coordinates of 0 and -1. And last but not the least, 0 degrees, 360 degrees, and other coterminal angles of 0 degrees will end up having the coordinates of 1 and 0. Okay? Okay, guys? So once again, if I have an angle of 0 degrees, what will be the coordinates? 1, 0. If I have an angle of 450 degrees, what will be the coordinates? 0, 1. Because remember, 450 degrees is a coterminal angle of 90 degrees. So again, guys, we're not only including the angles here, the angles that we use to learn the basics, but also we're going to include its coterminal angles. And what's coterminal angles again? Or what is coterminal angle? It's basically an angle that has the same initial side and the same terminal side, or in other words, the same positions. Okay? They may differ in terms of their signs or their values or both, but in terms of their locations from starting to end, they are the same. Okay? So we're good. Now, how about if we put a square inside the unit circle? We'll continue this one soon.